Manish Pandey and Manish Badarke kind of presenting the automotive enhancement support for the A-class architecture. So we'll get started with the presentation. So Manish.
Yep. Okay.
Hello.
Hello.
Have you started recording?
Yeah, I did.
Okay. Hello all. Me and Manish Badarke both are part of TFA, as many of you must know. And we are going to present today about our plans for.
Sorry, but your voice is very, very low. I'm not sure I'm the only one, but
Is it?
too slow.
Is it clear now?
It's a bit better. Thank you.
Yeah. Okay. Thanks. Okay. Just let me know if you have any issues in between. So yeah, we are going to present about our plans for AE enhancement in TFA. This is not something which we have implemented, but at this stage, we are kind of kick-starting our discussions around AE support in TFA, and we want feedback from partners because at this stage, AE platform is not very mature. The platforms which many companies are using or you guys are using is quite different than what ARM is thinking of. And at this stage, we are trying to understand all the requirements. And based on that, we will create our priorities and create tasks so that it will help everybody. So the goal of this presentation is to start a discussion around any AE related enhancements in TFA. So I will start with what our goals are and what are major changes we are expecting, and then what we have done so far. And also we have created some requirements which we think is we are going to implement or it will be needed in future. But feel free to send us any emails or by any other means to add any new requirements as far as AE enhancement is concerned. So the first thing is TFS so far has been used in mobile platforms and in infrastructure platforms, but not so far in any of the safety critical systems or safety critical platforms, especially in AE area. So now we have started getting ideas what all changes will be required in TFA to make it safety critical. I mean, to be used in TFA, used in safety critical platforms. We are also targeting supporting all the AE variants of ARM hardware IP, and primarily we are concerned about GIG at this stage and probably some changes in CPUs and not more than that. But going forward, if we think that something else is required, we are happy to take them up as well. As I said earlier, currently we are trying to understand partners' use cases and their requirements, and we will really appreciate if you have any feedback which you can give us so that we can add them to our action items. It will also help us in making our priority and planning. We are targeting to make a generic implementation as much as possible because, as you know, there are so many implementation in TFA which are targeted to ARM platform or some other platforms, and they are closely coupled to the platform. But with this implementation, we are targeting to make all the implementation as generic as possible so that it can be used by any platform without much changes. The other different thing here in AE development is as ARM, currently we do not have any platforms where we can test. So we might need a strategy where we can co-work together in developing any new features or any new enhancements and we may need help from partners who has platform ready to validate those features. And if needed, we could create a regular sync up meeting, which can be only I mean it for A related work items. We can create a sync up meetings, and those could be very technical ones where all the all the partners or all the engineers who are interested, they can join and have a discussion. So we can come up with something like a monthly meeting or something. I mean, we can think about that in future. So the majority of changes we are expecting currently are in gig 600 AE support. So gig 600 AE is nothing but gig 600 plus FMU, fault management unit, uh, which is responsible for injecting errors and handling those errors. In a real automotive platform, we are expecting this FME to be accessed by a separate R class processor in the system. So, so the idea of a automotive platform, which we are thinking of, is having some A class processors which are doing heavy processing, and there are some real-time processors which are responsible for making decisions, and they are critical for the system. So the system you are thinking of uh, will have a class processor as well as R class processor in the system, and and the gig 600 will be accessible for A class, but the FMU could be restricted only to be used by R class processor in the system. So all the development we are thinking about FMU, we are thinking of making development in TFA as of now, but we want to develop it in such a way that it can be used in other firmwares. Let's in future, if a separate firmware is created for R class. So so the so that's the plan now. The TRM for gig 600A is available for so long, but we do not have any support in TFA yet. So this is one of the action items from our side to give a minimal support of gig 600 AEIP. Last week I sent one email. So story so far, what we have done so far and what we are planning next. So we recently, last week I sent an email over mailing list about understanding the requirement from various partners. And if you have any use case, just reply to that email, and we can add it to our action items. Okay. Currently, we do not have any platform available to test the development which we are doing, but um, uh, so here we need your help. If you have any platform ready and you want to use TFA in there, we can surely collaborate and co-work on developing any features and validating it on those platforms. So so far we have identified some tasks which can be carried out without availability of a platform, and that we are now we have recently started working on those items. And once we are done with those tasks, we may then move to next, where we need a platform uh, to validate our changes. So one of the first tasks was, as I said, the Geek 600A is nothing but a Geek 600. Functionality wise, it is similar to Geek 600, and then there is an extra unit for FMU. So functionally, it should be similar to Geek 600, and that's what our first step was, to verify if uh, in a let's say, for example, in FVP platforms, currently we have Gig 600, and if we replace Gig 600 with Gig 600 AE and see if it works as is without any software changes. So Manish Badarke has done some experiments, and I mean, we saw that yes, they are functionally compatible and there is no software changes required there. So Manish, if you want to add something there.
Yeah, so we have model team separately over here, and they have given the model with Gig 600 AI capability in the FAP, and we did a whole test. We ran the whole TF test on that particular model with the same stack whatever we currently having, and looks like the results are positive right now. Not no any change, means not any changes need to do in the software. uh, as I think like this is particularly we are doing it on the model, but if any partner is having the real silicon, uh, real platform basically with Gig 600 AE, if they can try to run and see if any real hardware uh, issues or functionality issues are present or it is working out of box, that will give us a little infeed, and if anything need to be done we can add it into our to-do list and we can accordingly separate out those tasks, whether partner need to do it or our need to involve in that. Yeah, so
So
this yeah.
yeah, so ideally Gig 600, a system with Gig 600 should work with a Gig 600 AE IP also. Of course, not with any AE related features, but in the normal mode. Another work we have recently started, and Manish has pushed some patches for that, is to, so as you know, in TFA, most of the system topology is statically defined for platforms. So we are now trying to understand if we could make sure that, let's say, in a platform like Juno, where there are 6 cores, and uh, in a particular chip, if we remove 1 or 2 cores from there, it still works. So the fusing of a core should not have any impact on the system as a whole, and it should work as is. So that's one of the activities we have started, and Manish has pushed some patches for review. So feel free to go there and have a look if you're interested. So do you want to add anything there, Manish?
Yeah, so the basic idea, just to give some technical detail on that, like we made this Gig CR frame as a read-only frame for the fused cores. Currently, we don't have any fused cores, but just we just did some hack in the code or in the model to make some cores as a fused one, and then try to write it from core 0 into that core redistributor area to check the functionality and whether we are getting the data about or not. And that seems to be working fine as of now. But yeah, if any real use case is there from the partner, yeah, that will help to carry out more exercise over here. And anyway, the patches are already posted externally. The reviews are welcome. I'm getting the reviews and I'm fixing it one by one. But yeah, if anything else need to be done apart from this particular protection, yeah, I'm happy to do it on top of it. Yeah.
Okay, so this is kind of an introduction to what we are looking for and where we are going. So if anybody has any comments or questions so far.
So Manish,
Okay.
there's a question in the chat about
Mhm.
does this all mean that we're going to produce a TF trusted firmware R class work? I guess it's related to your FMU accessible to R class processor.
So I was talking about a hypothetical situation. I'm not sure uh, it's going to be a case for sure, but what I was intending was that a platform which has a class processor and a R class processor, and most of the companies, they have their own firmware for R class, and my emphasis there was to tell that if we are developing any firmware for FMU, this should not be tightly coupled with TFA, and it can be easily migrated to another firmware, which will be used for our class. So that was my emphasis there, to make sure that whatever we write for FMU driver, let's say FMU driver, it's easily portable from one firmware to another firmware. Does that answer the question?
Yes, thank you.
Yep. Okay. Another question in chat. Let me see.
Yeah, I think that was all.
Okay. Okay then. Moving on to next slide. So far we have, as I told, so far we have identified following tasks with help of some interested partners and our use cases, internal use cases, and that's the target of this presentation, is to add as many use cases as possible in this list, and so that in future, if anybody is going to use those features, or they are going to use TFA for AE platforms, they don't think that those features are not available. So we are not asking now to provide any requirement from your side, but if you think that there could be something which will be of your interest, please feel free to send us an email or something. So as we discussed the feature parity between Gig 600 and 600AE, we already kind of finished it recently, which we already discussed, and Manish explained about that. So another major work, and which we were discussing earlier, was the development of FMU firmware. So the FMU is like, it has to be detected first, and then it has to be initialized, and it injects errors which will be trapped to the processor running real-time R-class processor. So as I told, that we do not have actual platform available which has a R-class processor in it and Gig 600AE. So as of now, what we can do is we can just do a detection part, whether the system has Gig 600AE or not in it. But the initialization and other error injection things is not possible yet, because the FMU registers has not been provided access to A-class processor on fast models on which we are working now. But if in future we get those access, we can start working on it. But currently we are not targeting it. So all the action items where I have written ARM in bracket, that we have decided and we have put in our plan to work on. But those which are not yet have any name there, either we are not sure, or we do not have, or they have a dependency on platform which we do not have now. So in the part of FMU initialization and error injection, here we need support from partners, where if some partner has any platform which is ready and where they want to do FMU programming, FMU register programming, then surely we can collaborate there and trying to develop driver for FMU, and there we can help or co-work together. We can monitor your patches or review patches, and then if needed, we can go for technical reviews every month or so. The other major change in an AE system is the lockstep mode, which is a system where, let's say, the system has 4 cores, 4 A class cores, and if they are running in lockstep mode, one core, 2 cores are made a pair, and they run the same workload. and at some stage or some step, their values are checked, and if they match, then only we go ahead. So this is very basic concept of safety machines. So currently we are, what our understanding is that the CPU mode can be changed from normal mode to lockstep mode, uh, either during power reset cycle, or that can be changed during that can be changed dynamically. So if, say, for example, in future there are use cases which comes up like the mode change required dynamically, in that case we need change in our existing TFA code, where the number of cores has to be brought. So for example, there are two cores, core 1 and core 2, and then they are made to run in lockstep mode. Then uh, the the OS at the top should be only aware of one core out of that pair. Then it needs to be dynamically done in firmware, and TFA does not have those dynamic capacity as yet. So if any change required there, we have to develop some more code to make it dynamic. So I think so that could be a very major chunk of work. But if the use case is only for during reset cycles, where at the power reset time we decide that the course will be either the course will be running in lockstep mode, then that support will be easily covered with what Manish is currently doing here in his the fused off course work. So let's see if if the dynamic requirement is there from any of you, then we will do some more analysis to make code detection dynamic. Also, we are yet not sure what changes is required in Gig to support lockstep mode. So that is one of the things which we are not yet clear. But in future, once we go there, we will see if it works as is, or it requires any other changes in Gig driver. Any questions there? Now, there are some small tasks in Gig driver for enhancing its existing capability, like reading trace and PMU records. So that's one of the tasks which is like building on top of what we already have, and these tasks are not specifically related with AE requirement, but it's good to have, and we have to yet see if it impacts any AE requirement or not. So these are some features which we have started analyzing, and we will start work in near future. The second enhancement is keeping our RAS records alive during across the reset. So this is one of the tasks where it depends on platform, because most of the development we do at ARM, we do on fast models, and the reset concept on fast models is not very clear like a real silicon. So we are thinking, we are looking for any other platforms like Juno or something else which we can use to do demonstrate or understand this use case. So if you guys have any real silicon, you can we may need your help there also to verify these things. The other task is disabling GIG-R frames of fuse, of course, which is what we already discussed with Manish, and support for message signal interrupts. So this requirement we are not clear, or we do not have any real use case as of now from our point of view. But if you have any, just please let us know, and then we can look into it. So currently we are not spending any time on there, but surely we can look into it if there are really some use cases. And finally, saving and restoring of additional gig registers during PM events. So currently we do save and restore some of the gig registers during PM events, but if AE requires some more registers to be saved or restored, we can certainly, so the first task here is to understand the extra gig registers which needs to be saved and restored. So once we figure it out, that should be pretty simple to just add those registers in the list of other registers which are being saved and restored. So this is pretty much all what we wanted to discuss today. So now we can open for any questions or any discussions. So just let me know if you have any queries, or you can always reply to the mailing list. You can even, if you are concerned that you do not want it to be publicly in public knowledge, I'm not sure, but maybe Matteo can correct me there. You can send us email directly. So that's it from me. Thank you.
So
Thanks.
sorry, Bipin. I apologies, people. I'm not hosting today because I came late to the meeting. So thanks, Bipin. But just to follow up on Manish's presentation, this is all about us trying to reach out to our community and find if partners, contributors have got interest in this space. I appreciate it may not be the folks actually on this call today, and you may have other folks within your organizations who may be interested in this. This like all our tech forums, this will be uploaded and the slides. So do reach out to me, or if you're happy to reach out publicly on the mailing list, for more information and more discussion, we're keen to talk to people. As Manish indicated, we have certain test capabilities and others and lacking in some areas. So this would be very much a collaborative effort if you're willing to work with us in upstreaming any support for platforms on changes that we're trying to do in the core code. So I just wanted to say that please pass on this to any of your colleagues if necessary, and we can talk to them directly if folks on the call today are not so interested in this for their current work areas. I'll hand it back to you, Bipin, as you're running this.
Yep. Yeah, thanks, Manish, for the presentation. So, yeah, I would just open to the forum in case there is topics for discussion. Any other topics? Anybody want to discuss? I'm not hearing anything.
Sounds like we get some of our time back.
Okay. Yeah, thanks everyone. I'll stop the recording now.
Thank you. Bye.
Thanks. Bye.